All right, everyone, our topic for today is literal equations. Literal is a word that means actual. So what we're talking about here with literal equations is equations that actually have meaning in the real world. When we look at this first one in example 1, we have the area of a rectangle. That's one we're probably familiar with, and it involves 3 different variables. So that's what all of these kind of have in common, is that there's more than one variable. So we're not going to be able to always solve these equations. What we're going to do instead is rearrange them so that they're solved for one variable or another. So the way we're used to seeing the formula for the area of a rectangle, it says the area equals length times width. What that means is this formula is currently solved for the area. If you think of it in terms of inputs and outputs, we input a length and a width, and we get an area as the output. But what if we're in a situation where more commonly we know the area, and we want to find out the width? We know the area and the length, and we need the width. We can rearrange this same equation so that the W is by itself, and we call that solving this for the width instead of solving it for the area. And although we're saying solving, remember, we don't have all these values. So we can't say W equals something, but we can say W equals in terms of these variables. We can't get an actual value, but we can get it in terms of A and L. And we start off with an example here. It says, what if the problem were 4 equals 2 times W? So in that case, our area is 4, and our length is 2, and we're trying to find the width. We know how to solve that pretty easily. We just need to get the W by itself, isolate this variable. So we're going to do that by dividing both sides by 2 to cancel our 2, and we get W equals 2. So pretty straightforward when there's numbers in there. Now we can do the exact same process without the numbers, with just letters. So let's rewrite our equation here. We have area equals length times width, just like we did here. But instead of a 4, we have A. Instead of a 2, we have L. We're going to take the same steps we did here. We divided by the thing that's the coefficient of W because we want W by itself. So we're going to divide by L on both sides. That moves the L from the right over to the left and cancels the L's over here. Now we have W by itself, so we've solved for W. And on the other side, we have A divided by L. So just like we started with an equation of 3 variables with A isolated, now we have our equation of 3 variables with W isolated. So this is what we would call solving for W, and as you can see, it's just rearranging so that W's on this side. We could do the same exact thing for L, so we could say A equals L times W. If we want L by itself, so I like to highlight these, we want L by itself, we need to get rid of everything else that's on that side. Since we have L times W, our opposite operation would be divide by W to cancel, and then we end up with L on the, I'm going to write it on the left even though it's on the right here. We can write our equation in either order. L equals, and on the other side we have A over W. So now we've solved that one for L. Very similar process. Example 2 is just the same, but the formula is distance equals rate times time. But you see it's one variable equals the product of 2 other variables. So I'll let you work that one as practice on your own, and we'll skip down to example 3. On example 3, thinking in terms of what we just had, we have a variable equals the product of 2 variables, just like we had, but now we also have a constant times those 2 variables. We're going to handle this in very much the same kind of way. So first we want to solve for B. So we want to make everything else on the side with B go away. I'll start off by writing the equation A equals 1/2 times B times H. So the piece that we want to isolate is right here in the middle, and we have 1/2 times B and B times H. So what we need to do is divide by both of those things. I'm going to start off by dividing by H because that's very similar to what we did before. we had a equals L times W, and we divided by the variable that we wanted on the other side. So we'll cancel the H. I'm going to rewrite this. Again, I'm going to put this side on the left just because then I'll end up with B equals something, which is kind of the format we want to see here. So B times a half is the same as B over 2. And on this side now I have A over H. So now with B over 2, this is B divided by 2. To cancel the 2, we're going to multiply both sides of the equation by 2. Now we have 2 over 2, and that cancels out because those make 1. And we're going to rewrite our equation one last time as B equals, we have 2 times A. We always write our coefficient before our variable. So we'll put 2A divided by H. So that's how we would rearrange that one. Very similar process, but instead of just dividing by our other variable, we also had to take care of this constant. In this case, it was in the denominator, so we multiplied to get rid of it. But if we'd had 2BH, we would have divided by it. Solving for H is the exact same process. So again, I'll let you practice that one, and we'll move down to example 4. If you need time to practice that one or the other ones, just pause the video and then restart it when you're ready. So the formula for the perimeter of a rectangle is one you're probably familiar with. We have a length and a width, so we have the width twice and the length twice as we go around the rectangle. So our perimeter is 2 lengths here and here, and 2 widths here and here. So they give an example again with numbers. I'm going to skip over that because it's like what we did earlier, and we're just going to go into working with this equation here. We're going to try to solve for W. So as usual, I'm going to find where is W. Okay, so W is over here. We have something multiplied by W, but also something added to the term with W. And in our reverse order of operations for solving equations, we always want to deal with our add and subtract before our multiply and divide. So we add and subtract, then multiply and divide, and then if necessary, we deal with exponents. So just the reverse of our order of operations. We start off P equals 2 times L plus 2 times W. That's a terrible W. And we're going to deal with our adding and subtracting. So to get rid of this 2L and move it to the other side, we can subtract 2L from both sides. When we rewrite our equation on the left, I'm going to write this as P minus 2L. You could also write negative 2L plus P, but I don't like minuses in the front if I can avoid it. And that equals 2W. And now we need to get rid of this. Remember, this is 2 times W here. So we're going to get rid of the 2 by dividing both sides by 2. And in fact, since there's 2 different things over here, we're going to divide every separate term by 2. So anytime something is subtracted by a plus or a minus, we need to divide each piece of this by 2. We cancel out our 2 here, and we can cancel out the 2 here. And what we're left with is W, I'm going to write on the left, equals, and on the other side we have P over 2 minus L. P over 2 minus L, like that. So that's going to be our final answer for that one. Number 5, we have one very similar to how we started. The only difference is instead of the product of 2 variables, the volume of a rectangular prism is the product of 3 variables. So if we want to solve for L, I'm going to find that. L is right here. L is multiplied by W and H. So that just means we need to divide by both of those in order to rearrange and solve for L. So we have L times W times H. To divide by both of these, we can do that all at once, or we could do it as 2 separate steps. It's much more efficient to divide by both at the same time. We cancel out W over W and H over H, and we end up rewriting L, length, equals volume over width times height. So that would be our final rearranged version to solve for L, and I'll let you practice solving for W and H because it's the same process. Now we're going to move on to a more intimidating looking equation, the area of a trapezoid. So we have an addition happening in parentheses a 1/2 multiplied outside and an h multiplied outside. First, we're going to try to solve for h. H is over here, and we've multiplied it by 1/2, and we've multiplied it by b1 plus b2 altogether. So let's get started. We have a equals 1/2 times b1 plus b2. Those are the top and bottom base of our trapezoid. And then times h. Since we want this h over here all by itself, we need to get rid of the things multiplied by it. I'm going to get rid of the 2 first. So we have 1/2. We can cancel out 1/2 by multiplying by 2. That gives us 2 over 2 and cancels out a 2 on bottom with a 2 on top. Remember, 2 is the same as 2 over 1. So we're just multiplying by the opposite of this fraction, which we call the reciprocal. So I'm going to rewrite. We have 2 times a equals, we're still going to leave this in parentheses because h is times both of these together. b1 plus b2 times our variable h that we're trying to isolate. So since we have b1 plus b2 times h, we need to divide this thing away. So this is all just one thing together. So imagine this was 2 plus 4, we would just have 6 here. So this b1 plus b2 together is just one addition thing that we can divide by. So we're going to divide by b1 plus b2, like that. And we're going to divide this side by b1 plus b2 as well. We don't need to write parentheses here, but I'm going to write them this time just so you can see that this is kind of a unit altogether. And I can cancel out so imagine again, this is 2 plus 4, that would be 6, and 2 plus 4, this would be 6. So whatever this whole unit here is, this whole unit is at the bottom as well. So those cancel out. And then we can rewrite our final thing. H is here by itself now. And on the other side, we have 2a all over whatever b1 plus b2 is. And since there's nothing times those, we don't need the parentheses. I'll write them outside of parentheses here, b1 plus b2. So that's how we would rearrange to solve for h. And now we're going to try something more complicated. We're going to try to solve for b1. So instead of this one being h that we're solving for, we're going to try to solve for this b1 that's trapped inside of those parentheses. We start out the same way with our initial equation. A equals 1/2 times b1 plus b2 times h. The same way as before, we need to get rid of the things multiplied by the thing we care about. So we're going to take the exact same step of multiplying both sides by 2, and we also are going to end up dividing both sides by h. So we cancel our 2 over 2 here, and we're going to rewrite this as 2a equals b1 plus b2 times h. Since this is times h, to cancel it out and move it to the other side, we're going to divide by h on both sides. That cancels here. And we can rewrite this again as 2a divided by h equals, and now since this h times these is gone, these are freed from their parentheses. So there's no need for them to be contained anymore because they're not being multiplied by something as a distribution. So we're going to just put b1 plus b2, and now those are free. Our last step then, if we want b1 by itself, remember this is our one that we've been trying to isolate all along, we need to get rid of the plus b2, and we do that by subtracting b2 on both sides. When we do that, on the left, I'm going to write b1 as our final answer, and on the other side of the equation, we had 2a over h, and now minus b2. So that's how we would rearrange that formula to get b1 by itself. Now, a lot of times in algebra, we're going to be using equations that have an x and a y because we're dealing with equations of lines and linear functions. So you're going to see a lot of things that have an x and a y, and we're going to need to rearrange them into what we call a standard form or slope-intercept form. That comes in the form of y on one side, and on the other side, the slope times x plus b. Since we need y by itself, that works exactly like these rearranging of equations that we've been doing. So if y is here, trapped with this 4 and this plus 5x, we need to rearrange the same way we've been doing to get the y isolated by itself. So in our first example, we have y plus 9 equals x. The thing that's keeping y from being isolated is the plus 9. Our opposite of that would be minus 9, so we'll do that to both sides to cancel out there, and end up with y equals x minus 9. So since we want to get y by itself, we are going to do minus 9 like we just did. Now that we have this x and minus 9, there's a reminder. We can only combine like terms. So the y's are one type of thing, the x's are another, and the constants are another. So we can't put y's and x's together, or x's and constants, or y's and constants. They have to be separate things that sit next to each other and don't combine. Alright, so I'll go through one of these real quick and you can practice the rest on your own. They follow the same process that we just did. Our y is either plus or minus something. Let's do one where there's a minus. So number 2, to get rid of minus 7 on the left, we will add 7 to both sides. And then when we rewrite these cancel, we get y equals x plus 7. So I'll let you practice the others on your own. Pause the video if you want to take a few minutes to do that. For example 2, we're solving for y. The only difference now is there's x's on the left instead of constants. We handle it the exact same way by subtracting that thing and moving it to the other side. So here we would end up with y on the left equals 5 minus 3x. That's one way we could write it. It would be equivalent to write y equals and swap these two terms. So remember, this 3x is negative, so we could put the negative 3x first, and then this positive 5 after. The advantage of this is it's in our normal, what we just said, slope-intercept form, which is how we like to write the equations of lines. So here we have it in the form y equals something times x plus or minus a constant. So this is kind of our more standard format, but both of them mean the same thing. So it does say write the x term first. That is definitely preferable. Okay, so your turn to practice some of these. They're very similar to that example I just did, so go through those 3 on your own. And then when you're ready, we'll go to example 3, in which we have a negative y and some x's over here. We have 2 options for what to do here. Number 1 is, just like before, move our 2 x's to the other side. When we rewrite this time, we still have a negative y on the left, and we'll put our x's in front to have negative 2x plus 8. So then, to get rid of the negative in front of the y, we can multiply every term in the equation by negative 1. Which means we flip the sign of the y and the x's and the constants. We have to change the sign of every term that's added or subtracted. So the y, the 2x, and the 8 all get their sign flipped. So flip signs. Alright, so the other way we could look at this one is, instead of moving the x's and multiplying by negative 1, we could move the y. We could do 2x minus y equals 8, and we could move the y to where it will be positive. Now we won't have to deal with a negative y. We rewrite what we have here. We have 2x, the plus and minus y cancel, and over here we have y plus 8. Well, now we've bound up this y and this 8. They need to be taken apart, so let's move the 8 over with the x's. And then we can rewrite our final answer. We have y by itself, and on the other side we have 2x minus 8. Notice that that's the exact same thing we got here. After we flipped our signs, we had y equals 2x minus 8. So we could move the y to the other side and bring the constants to the left. That gives us all positive, or a positive y. Or we could move the x's over and then flip all of our signs in order to get the y positive. So there's some more practice for you on these. I will go through one of them together here. Let's just do the first one. I'm going to use the move the x's and flip the signs. So I'm going to do minus 7x on both sides. That gives me negative y equals negative 7x plus 8. And then in order to get the positive y, I'm going to rewrite this but flip the sign of every term. So this becomes positive, positive, negative. And that's our final answer. So practice the rest of those. And I think we have another example here. So when you're ready for this one, we're going to look at a case where now we have some x's with our y's, but more importantly, we have a coefficient in front of the y. So y is times something. So we're going to handle this initially the same way. We're going to do minus 2x on both sides to where our y's are all alone on the left, or whichever side. And you'll write the x's first, so the minus 2x and then the plus 7. Now to get rid of the 4 in front of the y, we have to divide by 4. But if we divide this by 4, we have to divide every single term by 4. We have to divide the negative 2x by 4 and the 7 by 4. So anytime there's another term, so our y term, our x term, and our constant term, they all need to be shrunk down to 1/4 of their size in order to stay equal. I'm going to rewrite this as y equals negative 2x over 4 plus 7 over 4. And so to get the y term by itself, we're going to move 2x to the other side, and then we're going to divide every term by 4, or the coefficient of y, whatever it is. And now we check if we can simplify anything. So y is simplified. Negative 2 over 4, those are both even, so I can simplify that fraction. And I could say that that's negative 1/2 times x, or negative x over 2. And then 7 over 4 I can't simplify because 7 is prime, so there's nothing that would be a common factor. So that's how we would handle one that has a coefficient in front of y. We have to divide every term, not just one side and the other side. We have to do each individual term divided by 4. Let's look at one more of these as practice. We'll pick one with a bunch of numbers, coefficients here. So let's do number 4. We're going to take away 5, bring it over to the other side, and rewrite 6y equals 18x minus 5. Now, since there's a coefficient in front of y, we need to divide every term by 6. We cancel out this 6, and we can simplify this 18 over 6 down to 3. So we have y equals 18 over 6 is 3, so we have 3x minus 5 over 6 we can't simplify, so we just rewrite it again as 5 over 6. So go ahead and practice the rest of this section on your own as well, and that should be all of our notes for today.